Okay. This video has to do with the law of sines. So, hopefully you can see that. Yeah, I think you'll be able to see that. So, the law of sines. Well, we know we can't use SOHCAHTOA here because this triangle doesn't have a 90-degree angle. It's not a right triangle. So, the law of cosines would require that... Ooh, they're awful loud next door. The law of cosines would require that we have 3 side measurements given, which we don't. What is it we're looking for in this case? Well, angle A has been given the variable theta. So, theta is the only variable in this diagram here that we haven't been given a value for. So, this is the angle we're finding. You'll be given instructions anyway. It'll say find angle theta, because side B also doesn't have a value. Angle B also doesn't have a value. So maybe you could get confused by looking at this and think, does he want me to find B? Does he want me to find side measure B? No. I want you to find angle A, because it's been given the theta variable. So, what does the law of sines say? Well, the law of sines looks like this. A over the sine of A equals B, lowercase b, right, over the sine of uppercase B. Side measurement C over the sine of angle C. That's what the law of sines says. But what does it actually mean? Well, it just means any side of the triangle over the sine of its opposite angle equals any other side of the triangle over the sine of its opposite angle. And you can only have one unknown. So, if we look up here, well, we're looking for A. Do we know the side that's opposite to it? Yep, it's 22. We also have another side that we're given, and we know its opposite angle. So, we can set up an equation using those values, and there will only be one unknown. So, using the law of sines, we'll say A, which we know, over the sine of A, which is what we're looking for, equals C, which we know, over the sine of angle C, which we also know. So A is 22. Sine of A, that's what we're looking for. So you can call it sine of A, you can call it sine of theta if you want. Because in this case, A and theta, they mean the exact same thing, right? The measurement of that angle. C, we know C, it's 17. The sine of C, we know angle C, that is 42 degrees. So, side of the triangle over the sine of its opposite angle equals another side in the triangle over the sine of its opposite angle. And we only have one unknown, theta. So, we're set up. We're ready to go. Let's see if I can move this camera there. So, what do we got to do now? Cross multiply. So I like to do the cross multiplication that involves the variable we're trying to find first, so we can keep it on the left. So, sine of theta equals, sine of theta times 17 equals this cross multiplication here. Sine 42 degrees times 22. So, the only thing we want to find, is theta, which is on this side. But we got some other stuff over here that we don't want. This times 17, we want to get rid of that. So, if something's being multiplied and we want to get rid of it, we divide both sides by it. Don't mind me switching back and forth between colors here. So, we divide both sides by the 17. We wanted to get rid of the 17 on this side, so we divided by it. If you do something on one side of an equation, you have to do it on the other side to maintain the equality. So, the 17s cancel out here. We're left with sine of theta equals all this stuff over here, which we can do on the calculator. Sine 42 times 22 divided by 17. So, remember, angle measurement first. 42 sine times 22 divided by 17 equals 0.87. So, just about there. The last thing you got to do, we're trying to find the value of theta, not sine theta. The only thing we want left over on the left side of the equal sign is theta, so that when we get to the end it says theta equals this value. So we're going to get rid of sine. Now the way you get rid of sine when it's paired with a variable is you bring it to the other side of the equation and it turns into sine exponent -1, which is the shift function of your sine on your calculator. So, shift sine, well, all you do is you press the shift button again, and then you press the sine button, and you get the yellow function above the sine button, which is sine exponent -1. So you put in the number first, 0.87, then shift, then sine. And you got your answer, 60.46. And once you get your answer, it's helpful to look back up and see if it's a reasonable answer. If I got 400 here, that's not reasonable because all three angles in a triangle add up to 180. If I had 140 here, well, 140 plus the angle I'm already given is 182. So that would leave no value for this angle right here. We'd already have exceeded our 180 degrees. But 60 seems reasonable. 60 and 40 is 100, and that leaves 80 degrees or so for that angle there. So it's definitely reasonable. If it was 2 degrees, too small. 150 degrees, too big. So it's a good way of checking to see that if maybe you might have done something wrong. But it looks like I did everything right because this number is reasonable. I followed all the steps properly. And yeah, if I did get it wrong, feel free to let me know.